Good evening, YouTube. How's everyone doing?
Hello.
I've got something to admit to. I've been very, very excited about this one. We have Sam and Mareen with us from SciReef in Germany. I'm really interested to talk to you guys tonight. That's for sure. How are you doing?
Thanks for having us.
Yeah, thanks, Steve. Thanks for having us.
Good. And of course, we have Harry with us as well.
Hello.
It's been a little while since we've had you on, Harry. We haven't seen a lot of you just recently.
It's been on here, yeah.
So how have you been
all
keeping?
That diving. Yeah, very well, thank you. Very well. Excited to be qualified. It's soon now. It's sort of end of April.
And then you'll be BSAC certified diver?
I will, yes.
To
indeed.
what depth?
Be 20 meters to begin with, and then 35.
All right. So you're doing an extra course for the extra depth?
I think I'll go to sports diver.
Okay.
I'm undecided. I keep back and forth because you think if you're diving abroad, really everything's going to be at 10, 15 meters anyway that we want to see. But I think the sports diver, it comes with some extra bits with doing saves and rescues. You cover that in ocean diver, but yeah, it's just a bit more in depth, and I think it'd be some good skills to
a little bit deeper than Paddy. Paddy's 18 meters.
Yes,
is the default one, isn't it?
Yeah, slightly deeper.
So you can swim beneath the Paddy divers.
Yeah. I think it's just it's that little bit more involved, and really it's quite hard to become like narcotic above 20 meters. And if worse comes to worse, if you shoot up from 20 meters, it's somewhat unlikely that you'll get bent as well. So I think that's why it's about that range.
Yeah. Brilliant. Let's have a look to see who we have with us tonight. And of course, the reefing man himself, the reefing god that is John Wright, who is in every live stream. I don't know if the news of John Wright has made its way to Germany yet, but he is on all of the live streams. Yes. He is at all of the reef meets, and just a genuinely real nice guy. So great to see you tonight, John.
Hello, John.
And
Hi,
then
John.
we have
Hey, John.
Neil.
Neil, how's it going?
Yeah, it's good to see you tonight, Neil. Who else do we have? We have Anthony as well with us.
Hello.
Good evening, Anthony. Harry West with us. Got to meet Harry at AOC at the weekend. It's good to see him. As well as Terry Teckers, who was also at the Reef meet.
Terry.
Good evening. Hope you're doing well. We have Impatient Reefer as well. Jamie. Pretty sure I've remembered it correctly again.
Jamie.
He introduced himself to me at the Reef meet and said, "My name's Jamie. I'm the Impatient Reefer." And I said to him, "You'll probably have to remind me your name a couple of times before it will stick." But it stuck straight away.
I love the name.
We've got Mo with us as well. Good evening, Mo. Mo has the most Strattons of anyone I know. He has 12 Stratton Pro 204s, these ones. 12 of them above his tank. Wow. Good evening, Dan. I hope you're doing well. I saw you've done an update on your Autumn Nature tank. Yes. I haven't watched it yet. Had a busy few days, but that's on my list to catch up on. Dan was also at the Reef meet, along with Lee, Bristol Reefer, was there as well. Good to see you. How many other we've got? We must have some more on here. Matt is with us. Good evening, Matt. Again at the Reef meet as well.
Hello, Matt.
Dave is with us. Good evening, Dave. We have Gary as well. Good evening, Gary. Any more in here? Lots of people talking to one another. Geordie Scott. I don't recognise that name.
No,
it's a new one, I think.
Good evening.
Good evening and welcome. What a live stream to join.
Yeah, certainly.
Reese is with us again at the Reef meet. Good evening, Reese. Myla is with us. Good evening, James. Dave is with us as well. Hey,
Baby
Dave.
Dave. How's it going?
And Chris is with us. Good evening, Chris.
Loads in tonight.
We have got loads. You've drawn a crowd, guys. Peter Parry,
P. Parry.
another reefing god.
Yes, good to meet
Grows
you.
some amazing coral.
Hmm.
Peter Parry. Yeah.
Oh.
Good evening, Peter. I'm seeing people saying hi to Liam, and I haven't clicked on him. There we go. Good evening, Liam.
Hey, Liam. Oh, Liam, I've got to get back to you. I will get back to you shortly.
Cryptic. Good evening, Scotty. Hope you're doing
Hey.
well. Another one that I don't recognise here, Sim Jakal.
Hey,
Good
evening.
evening. Any more in here? So we're almost at the end. Reefing Mad is with us as well. I want to say Chris. I think it's Chris. If not, sorry.
Evening.
I love you, Halfish. Good evening.
Evening. Notice I skim around it. Should put it on schedule. Depends on a lot of things. Depends on your nutrients and yeah. Do some testing.
And the dimension of oversizing.
Yeah. If it's bigger than your actual tank, they probably don't want to run it all the time. Good evening, Steve. We're almost at the end now.
Hello.
It was Chris. Good. And that is it.
Hey, Chris.
And you don't need to get back to Liam. He'd forgotten about it anyway.
Don't worry then.
So, Sam and Mareen, or Dr. Muller. So, give you your proper title. It's probably well earned. Yeah, like I say, I've been really, really excited to do this one. I never dreamed that you would say yes to coming on. So, thank you for agreeing to come on. You've sent me lots of pictures and video that we'll share as well throughout the evening. Wow, is all I could say. I was just going through them, and I show my wife, and I'm like, "Oh, look at this one." She's like, "Yes, it's a coral." I'm like, "Oh my god, look at this one!" But just phenomenal corals. So I was introduced to Sam at the TMC Reef Summit last year, speaking. I think you spoke after Jamie. Did you? You were after Jamie, weren't you?
Yeah.
And I thought when Jamie spoke with us, that was going to be all we heard about coral spawning, and then you came on and you just kind of introduced a whole new level of the information to take in. It was really interesting to hear you talk, and I wonder if you could share with us tonight kind of how SciReef started and what is it all about.
Sure. Yeah. First of all, thank you so much for having us. And it was a great pleasure to be at Reef Summit and present what we're doing, or back then more like what we were up to, because back then sales haven't started yet. So right now, like since November, we're actually getting our baby corals out into the big wild world. Generally we're started off in the field of coral science, coral research about mostly juvenile corals, and the differences between juvenile stages and the adult ones, because adult corals have been researched for many decades, so a lot more data have been collected for fully developed corals, and the babies are vastly different. So they're like a wholly different organism, and that's what we got into in like 2010 was the first time we went to Guam, like in the Western Pacific, for our bachelor theses. So back then we were both at the University of Würzburg.
Yeah, so we both started, and then we started working first with larval settlement and then with the different juvenile stages. because basically when you want to know a stressor like sedimentation or heat, what it means for coral reefs, you cannot only study the adult animal, you have to study the different life stages, of course. So that's what we were up to, and that's what we started doing. But then we quickly learned it's not that easy to get these little corals, and that's a good reason why nobody's studying them, because it is so hard. So we first had to get better at getting these little corals to do experiments with, and we did that. So we did get quite a bit better at it. We learned from a great colleague from Japan how to spawn corals and how to get them to settle, and then we continued to develop the methods and stuff and got better at it.
So over the years, so
at some point we had
back in 2010 was the first time we went to University of Guam, Western Pacific. It's a great facility. Guam, definitely one of my favorite places in the world to be. It's an amazing island. It's part of the United States. They have their own university, a great marine biology institute with like flow-through facilities. So the reef is basically 50 meters or 50 yards down the hill, and there's a reef flat and the reef slope, and there's all the corals right there, right? And they have a big pump at the beach that brings up all the reef water. So you have perfect water. You got the sun shining for free from above. You got the moon shining, so you don't have to worry about any of that. So it's a fantastic place to do research. And then we almost every year for the mass spawning, we went there. So the mass spawning on Guam of the acroporids, it's usually depending on when because it's tied to the full moon, like the moon cycle is giving like the pace, and then it's either in July or August. So we would either usually go in a little bit before the estimated date and prepare everything, then get the corals from the reef, have them spawn in the institute, collect the eggs and sperm and do the fertilizations, produce the larvae to produce the baby corals for the research projects. And with every year we got more efficient and got more experience, because a lot of the, I would say, the efficiency depends on how much experience you have to handle these tiny little weird organisms, right? And then in 2015, we had about 30,000 little acropora that were settled, and they were about almost the size of like a euro cent. I think that would be like, I don't know, what's your smallest coin you have? Probably
they were
half
about
the size
half
of that.
Or something.
So we had like 30,000 of these guys sitting in the tanks, and me being like basically lifelong aquarist or hobbyist, was asking Mareen, hey, do you know what you could do with that, or what that would mean for the hobby, for the whole business, if you could enter these into the market?
Nope, because I was never like a hobbyist. I only saw these organisms from the scientific side, really, I have to admit, at that point. But that was basically when the idea was born, like maybe we should do this for the aquarium trade. Maybe this would be actually really, really cool to get like a whole different
it has so many different aspects and facets that would bring like new how would I say, new aspects into the coral hobby. So we thought in 2015 we should really pursue that, and then from then on, all the projects we worked on, like our PhD theses that were also about like heat tolerance in juvenile corals, but everything was always geared towards the goal of
starting this company.
Producing corals for the aquarium trade. And then after about 10 years, then
only took us a little while.
That background,
like in 2024, we were finally then ready to launch SciReef. And
so basically, for everybody who does not know it, maybe we should explain what we actually do. So we launched our company SciReef in 24.
Yeah.
And so we only produce corals through sexual reproduction. So we have coral spawn in our facility. We collect the gametes. We have the embryos develop into larvae, have them settle, and then grow them out. And only those real baby corals leave our facility for the aquaria trade. And that has a lot of big advantages.
There's a lot of really fascinating aspects.
It is really difficult still for us. There's a lot of disadvantages, but it also has a lot of big advantages.
Yeah, once they are past a certain age, then it has a lot of advantages. I mean, we can go through all the different aspects that make them.
Yeah, so we've got some questions. I will just quickly go through because we've had a couple of extra people show up. So we have Julian Paul, Jupiter's Reef, with us. Good evening. We have Mike, who's with us, who's a previous guest on the live stream. Great to have you on. And 100 apologies, Lee. I forgot Lee when we went through. It's really easy to miss someone. So sorry. Good evening, Lee. It was great to see you at the weekend. So Mo has got a couple of questions here. He says, how many different spawns do you have? At first I thought he meant how many different species, but I think looking at his follow-up question, how many spawns per year do you get in?
Yeah, that's a very good question because it stretches out. We have different systems, right? So the spawning time is different in different biogeographical regions. Like in Australia, it's usually November, December, January. Some outliers go into March. So actually, like in the next couple of days, we may have some of the acros go in the Australian system. Then we have Fijian system that starts in like September, but also depending on species, it stretches out a bit. And then we have a Saudi Arabian system with corals from the Red Sea. These go usually between April and June. So I would say in total, like at the presentation I gave at Reef Mania, I think I listed like 35 spawning events, but it's probably, that was an updated presentation, so it's probably quite a bit above that. So I would say we had like 40, 45.
That's a lot more than I was expecting.
The question is, what is a spawning event? Because sometimes you have a species, let's say you have 10 colonies of Acropora tenuis or Kentai, right? And then 2 go on Monday, and then 1 goes on Tuesday, and then 3 go on Wednesday. And then
you can call all of these spawning events, but when you can't make any crosses because it's one colony, then I wouldn't really count it as a spawning event.
Yeah, but also if you can make crosses, then I would call the entire thing or stretch, I would say 1. So I would say around 40.
Yeah. So if you took like Fijian corals, for example, would you have 1 per year at the standard time that would happen? Or have you tried to kind of adjust? Because I've heard people saying you can.
Yeah, you could. I mean, you can shift them. You can. You don't necessarily have to do it at the exact same time. You don't have to put the same moon and sun cycle and temperature cycle that they have in the wild. You don't necessarily have to do that. You can switch it a little bit if you shift this, but then it takes time for them to adjust to the new time scale. And when you want to still import something new, then they might be out of sync. So we haven't really played around with it much yet. We might do it in the future. A little bit, yes, but not like we only have like 3 systems now. So there's not like, and these all run at the same time and temperature, or kind of same temperature.
More or less,
More or less. So we don't have like 10 different systems yet where we could say, okay, these 5 Australian systems run like 6 months ahead or something. Would be nice, but not yet.
There's like 3 main factors that induce the spawning or the time, the scheduling, because the coral has to know what day it is. So that's the baseline, because they sit in the reef, they can't move around and find partners to make babies, right? So they have to know when is the right day that the other guys and gals are spawning, so we can create some offspring. So, and that is they can get that information by the lunar cycle that gives like the general rhythm, right? So they have light receptors, and they can recognize when there's full moon, the entire night is some light impulse, basically.
Yeah.
So there is no darkness during full moon. During new moon, there is darkness the entire time, right? So that is like the ground, or like the background rhythm, right? And then on top of that, you have the temperature curve throughout the year that gives you the seasonality and the day of length. Although I'm not sure how important the day of length actually is, because right at the equator, it's not shifting too much. But anyway, so these are the factors you simulate, and then they know what day it is. And the fascinating thing is that, and we did that before with our Acropora austera, that you can take a coral that has been in a system that every day is the same for 20 years. Like we got the austera mother colony we got from the Natural History Museum in Karlsruhe, and we put it into our Australian system. And then it took 1.5 years for it to kind of clock into the
That's cool.
seasonality, and then it actually spawned.
A lot.
It spawned a lot, yeah. I mean, the whole colony was about like 50 kilograms.
Yeah, it
probably.
was a huge colony, and
Wow.
was a
So
lot.
how often do you imagine in like hobbyist tanks that aren't purposefully running any sort of moonlight kind of settings or anything like that, how often would you guess that there are corals spawning in hobbyist tanks?
That's a good question. I would really love to know.
Yeah, I think it's more often than people assume, because we also had it with our tumida, with the Ensman in the institute system that produced
Yeah, that
a
was
ton of eggs.
in a system.
Yeah,
You cannot rub in his beard.
I was told to not scratch the beard because it does the on. Never mind. So
So we know it happens, but it's really hard to say. Like, I mean, yeah.
If the coral is happy, if the conditions are right, and it's well fed or gets enough nutrients, it will try to procreate, right?
Yeah.
So the idea
Probably,
is
yeah.
the moonlight, as you say, is more to get them spawning at the same time,
Yes.
rather than like a necessary part of the potion, if you like. It's more just to get them going.
I think both. I don't think that every coral that we have in the tank will spawn at some point. I'm pretty sure some will never do it, and there's just like there is not the point that they get induced to produce eggs and to have them develop and everything.
But I think it happens on a regular basis, but you just can't predict it.
Yeah.
I mean, the only way in like a regular tank is to break off branches and have a look inside to see if there is eggs inside and what kind of developmental stage they're in. Because in the acros, they usually take about 6-7 months for the egg development.
Depends a bit on the species.
Yeah, some are quicker. So there's like the Moricata that goes twice a year, but most of the acros go only once a year.
Yeah, and for most of them, you can see it before they spawn. For the 2-3 months before they actually spawn, you can see the eggs inside. In the beginning, they're really white, but when they're ripe, for most species, they're pretty like pink, orange colored. So if you would do frags or something of your corals and you like always have a closer look, you can see something.
Yeah, always look inside. Yeah,
it was really interesting when we had the first audience with Reef Meet. Jamie was speaking there, and it was in a town just outside London called Harlow, and right next door to the hall where all of the talks were taking place is quite a big coral shop in the UK called AAC, and they had arranged this event and they were hosting everyone, and basically we convinced Paul, the shop owner, to let Jamie go into the shop and break a colony open to check to see if we could see any eggs in it, and I managed to kind of go through and record him breaking the coral open and looking for eggs inside, which was really interesting.
Did he find any?
Yes.
Awesome.
Yes. Yeah. Because as part of his talk, he said, if you've got some corals next door that have been imported in the last few weeks. So
Yeah.
the likelihood is that they will have eggs in them.
Yeah.
And then we kind of just strung arm Paul into letting Jamie break one of the corals open. Let me see if I can just share my screen. I tried to download. I was going to just download every single picture you sent me, but then when I looked, there was so many you sent me that I thought it would be easier if I share my screen and we just kind of step through them as we're going, kind of thing. So let me put this picture on the stage. So I'll just kind of go through and you'll have to shout stop, and we'll stop on one. You tell us about it. But
so maybe we can
have a lot
talk about
here.
a little bit. So we have 4 different species that we sell corals from now.
Maybe we should do a little more broad description of the kinds of categories of corals we have. So we have, I mean, every single coral that is sold by us under the SciReef name has been grown from an egg here in the beautiful city of Wilhelmshaven in northern Germany. We have one type of coral that we call unique corals, like especially the Kentai from 2024. That means the coral is grown from a single larvae or multiple larvae. We can come to that later. But this coral only exists a single time
and has never been
fragged. So whoever buys the coral buys the entire genome of the coral, and once it leaves our door, it's gone, right? So the person buys it is the only person on our beautiful planet who owns that coral. Of course, these are a bit more pricey than like a standard coral. But
of course they're limited, however successful we are from each spawning, we have a limited number of unique corals. But then to make it a bit more affordable for everyone, we also do frags of our corals. So we don't sell all unique corals, we put some aside that we frag and that we keep fragging over time, and then you can buy frags from those, and we call those twins. So we have unique corals and twins, and the unique is always more expensive, but they have these gorgeous growth forms, these shapes that you can only get from a never fragged coral that I think they can just be extremely beautiful. And then the cheaper version is the twin that look a bit more like a normal frag that you would buy from.
I mean, they still grow out into a beautiful colony,
just like other frags can as well, but they need more time. And with the unique ones, even when they're small, they have this perfect colony shape already, like a kind of like a bonsai tree. It looks like a big tree, just in small. And you have this with the juvenile corals as well. They look like perfect little colonies, just smaller.
That's got your name all over it, Steve. Give it a week.
And with the twin corals, of course, there's multiple individuals multiple I would say corals of the same individual, so you're not the only person who bought that entire genome.
So for the unique corals, we only have one species that we are selling at the moment, the Acropora kenti, or the tenuis from Australia, basically. That are now 14 months old, all the babies. This was the first
15, it's March.
Or 15, it's March, okay. That was the first really big spawning we had in our facility that was really successful, and we had a bunch of these off. So we can sell those as unique corals. And then we have some that we spawned a little bit earlier, where we only had like a much smaller number of individuals from, but they are already a bit older, so we can make frags of these. So we have a couple of species that we sell as twins now.
I mean, we can go through the species. Since Steve already put up the pictures.
So this is Nasuta, which is not very commonly found in the aquarium market, I think. I think sometimes maybe people call it different names. Honestly, like, you might call us Acropora specialists, but the names of the species is really hard for us as well. And I think everybody who pretends to know everything is
so if it comes to the identification of acros, I would not be the first person to ask.
But we had a specialist ID the parents of these, so we are very certain these are called Nasuta, or as certain as you can be.
Yes.
Yeah, and I have to say the Nasuta is a really nice coral because it has this table forming growth. When it gets bigger, and has this the really vibrant growth tips.
Yeah, and they have very like thin branches. They don't get too like bulky. They get really like really beautiful, fine branches. They're gorgeous.
That reminds me a little bit of Purpleberry, Steve, from Eden Corals.
It does, yes.
Yeah, the colours and the growth on there.
Yes, yeah.
Yeah, and then we have Acropora austera. This was the one we talked about with the one parent we got from the museum that was been in the trade for a very long time. And yeah, that was really interesting because we had two parent colonies. We can basically say we had one really big one and one very small one. So we had the eggs of like one colony, and then the sperm had to basically fertilize all these eggs. And both of these were green. Like completely green, like barely any pink tips or anything. And the juveniles, they look so different. We have some that are vibrant yellow fluorescent. We have some that are really strong green fluorescent, much more than the parents. And then we have some that have that are completely pink with yellow tips, and then a lot that have like these gorgeous pink and yellow tips.
Sorry, Sam, you go.
Yeah, no, I just want to say that's a fascinating thing about the genetic diversity, right? So we basically, with that type of reproduction, you mix the genetic traits of two individuals, right? And if you have 100,000 fertilized eggs, you have 100,000 unique, distinct individuals, which all carry different traits, and that reflects greatly also in the color variation. Even in species like Austera, that usually is not that variable, but in these guys, it's very surprising how different they look.
Yeah, and we were not sure about, because like Acropora austera is not like a lot of like acros, especially like acro freaks don't really love austera so much. It's a pretty easy species. A lot of people, it's like kind of a beginner Acropora maybe, but not that attractive. But like just yesterday, there was a reefer at our facility, and for him, it was the highlight. He said, like, it's the most beautiful acro he's seen in a while. And he was totally blown away by how beautiful these Acropora austera can look.
Yeah, I think it has been a bit of a neglected species in the recent years, I have to say. And
we're changing that now.
Yeah, one funny thing is, as we mentioned, the mother colony. So all acros are hermaphrodites, right? So they release eggs and sperm packed in little bundles and rise to the surface and then dissociate, and the eggs are on the surface and the sperm do their thing in the water. So we had one really large colony that we collected a lot of eggs from, and sperm, of course. And then we had this smaller colonies from Fauna Mareen, from Claude. And that one released a very small amount of bundles, like egg and sperm bundles, right? But it was enough to
fertilize these eggs.
To fertilize all the eggs, right? And that's why we know we always joke that the dad is Claude and the mom is Hannes from the Natural History Museum, because the amount of eggs from the dad colony was so small that I didn't even.
So it's kind of funny. Like Hannes is really a famous reefer here in Germany as well. He's so gifted. Like he has the most beautiful tank there in the Natural History Museum that I have ever seen.
He used to be so he just went into retirement, but he's still working with them. Yeah. So he set up a 270,000 liter coral tank in the museum that also has sharks in it. So the combination of sharks,
coral diversity I've ever seen in an aquarium by far. Like the diversity is insane that he has in there. It's not just beautiful. It's
he is a legend.
So he's the mom of these.
Excellent. Did you have a question, Harry?
Yes, I was going to ask in terms of, because of course all of these different colors and almost slightly different branching structures from what I can see, are they passed down from like previous, like how many can't think of the word, but how many corals back can it go? You know, like some people look more like their grandmother than their mother, for example, that kind of thing. Does that apply here?
Well, we only have the first generation. Our babies have not spawned yet. We have some of our babies that are 3 years old now in the spawning systems, and we hope to get second generation soon, but we have not so far. So we are just blown away by how huge the variety is in the first generation, and like how, like, even if you have only 2 colonies or 3-4 colonies from which you get the babies, how vastly different the juveniles can look. And I was always thinking like, okay, if you have like a tenuous, we know it can be very variable, but maybe it's like genetics are a little bit more different, or the location where it grew up was very different, or the tank in which it grows is very different. And we know that all these factors make a difference, but we have siblings, they even like fuse into chimeras. They are so closely related, and they've always been growing at the exact same point all their life, and they look completely different. They have different growth forms, they different colorations. Some grow fast, some grow slow, some have thin long branches, some have short sturdy branches. Completely different. And obviously like nutrients, light, current, everything has been the same. So the individual genetics is
I would say the short answer about like transgenerational passing of colors is we have zero idea. We have no idea. It's a complete black box. So if I take a blue kentai and a yellow one, there's not only going to be green babies.
Oh, but we do have a little bit of an idea, actually. That is really, really interesting. Maybe we come later to some photos. I'm not sure if I sent you some, but what was extremely interesting, we imported some corals from Fiji, some tenuous from Fiji we had spawned, and they all looked like typical tenuous. And then the juveniles, they look very, very much like Echinata.
Yeah, some of them. So there's like a gradient, but I think there's probably pictures, so we can go over that later.
So, and actually Echinata and tenuous are pretty closely related. So we actually think that in those that look like tenuous, there might have been some Echinata genes in there that showed up in the generation later. Because like seriously, some of them, they don't look like, they look much more like Echinata than tenuous, and we didn't have an Echinata spawn there, so it must have come from somewhere.
Yeah.
Wow.
It's definitely sounding like we're on the brink of like discovering just so much more about these animals.
It feels like we're at a stage where we were with the clownfish like 30 years ago. So now we're able to reproduce them or procreate them in that way and do all the crossings and targeted crossings to figure out what can be done, because the underlying process, whether it's a cat, since I see our fat cat here right now, or a guinea pig, or tulips, roses, what have you, it's always been it's all the same, right? You just have to figure out how certain traits interact. And with corals, I think it's pretty complex, because especially in acros, I think they're by now, regarding the coloration, there's like 90 color proteins have been described. So we know that the coloration is composed of like a vast variety of different proteins that they produce, and then which genes I don't know, produce which proteins. I've got no idea, to be honest. So
well, let's step through some more pictures that we've got here.
So we the twins basically of the Kent, we always do, and we grade them basically. So we have such a huge variety of colors. We can't give 2,000 different individuals of funky names. So we just said, okay, all the ones that have like one color that are just like turquoise, they're grade 1, that have like different colors, they're grade 2. And when we have the most beautiful of the beautiful, the top 1%, we call those grade 3. And that's basically a little bit of the price ranges as well. And so for the twins, we have grade 1 and 2. And so, that's
for the unique corals, for the ones that only exist a single time, we put them into 4 grades. So we have the grade 1 are the one, I think they're all really beautiful, but grade 1 is the colors that are the most common, I would say. So if you have a batch of, I don't know, a couple hundred or, I don't know, 1,000 corals, and that one particular color is the most common, of course, then these need to be in the lowest grade, basically. And the grade 1 also are more the ones that have a single color type, right? And then the grade 2 are the ones that have more popping colors and a really nice morphology. And then in grade 3 we combine like super nice morphology and really popping colors that are rare. And then we have the grade 4, which are the chimeras. So these are the ones that are fused individuals. They consist of multiple individuals that settle closely next to each other and then fuse together. And that is a really fascinating phenomenon.
I think we'll see pictures of those later on.
Yeah, we can go into that a bit later.
So let's see what else we have in here.
Yeah, these are just more ostras.
Yeah, they all look great. They're just these, you're saying? They're just wow, they still look fantastic.
Yeah, there we have the chimeras.
Yeah, there's some of the chimeras. So they're composed of 2 different individuals. So we have one side of the colony that is pink and one side of the colony that is purple, because they're composed of 2 different individuals. And we don't have many of them, so they're really, really pricey. And I apologize for it. This is not affordable for most reefers yet, and I feel a bit ashamed of but we cannot, of course, give those few away for a cheap price, and we wouldn't have any anymore. But we're working on it to make it more affordable.
I think to those people, a lot of people watching will know what it costs to run a reef tank, and I think it's probably sensible to imagine that it's going to run a facility like yours by no means be an easy feat financially, nor all your time and effort that must go in and research and goodness knows how many hours and years of work. So
it's been a long time. So it was important for us to have also affordable corals. So the twins start at €60, so it's more in a common price range, I think, and that's fair. But yes, the very few of the most special ones, they are quite a bit more expensive.
Yeah. So we have a wide spectrum of price range. So like the standard price range, and then
define pricing. It's killing me.
Mike is saying, "Come on, tell me how much is pricing."
So standard retail price for the chimeras is currently €1,000.
Okay. Yeah, I mean, I've seen pairs of fish for multiple thousands. So
yeah.
I would be too terrified to. I start to get worried at about €150.
We didn't take one home, so
at Reef Mania we had 4 with us, and they all found new homes.
Yeah, I'd be too worried about killing it. Just
although that's a different topic we can go into later, because
imagine they're more hardy. I think we'll all have to pull in, Steve, and we'll frag the frag into 50 frags, and then one of us might be able to keep one.
But that is really interesting. Like that was also one big aspect that we were totally convinced of, because we studied juvenile corals intensively, right? From especially like from the scientific side.
15 years.
Yes. So we knew that juvenile corals are very different than adults in multiple aspects. Of course, in the beginning, when they're so tiny, especially the first weeks, the first couple of months, they are so sensitive to all kinds of stressors, and anything can eat them and kill them and overgrow them. And it is a pain for us to get them to the point of like 3 months. But afterwards, they like when they grow up under aquarium conditions, they are so much easier to take care of than the imported corals.
Yeah.
The difference is vast. I mean, we have the imported corals and they annoy us every day. We have all the problems that everybody else has with corals. We have them too, but not with the juveniles. There are rarely any problems with the juveniles, and they are just a joy to see grow. They grow so much faster. They are healthy, and they just thrive.
Yeah, I mean, they've never seen a reef. They only know aquarium conditions. We grow them up under like standard conditions, like 25 centigrade temperature, and we have rather high nutrient levels, like 0.1 phosphate is like our target concentrations, nitrates between 1 and 5, and so we don't do anything fancy with them. So they're just adjusted to it, and it's kind of like, I mean, nowadays you, So I mean, nowadays you can buy like mandarin fish that eat that dry foods, right? Like 15 years ago, nobody would have believed that this is possible, but this is the exact effect that we see also in corals, that they're, once they grow up under the aquarium conditions, that's what they know, and what they like, and
and there's one example that we know. For example, they don't have symbiotic algae at the beginning, and as juveniles, they can go into symbiosis with different kind of species, let's call them, and go into symbiosis and be in symbiosis with those kind of symbionts for the rest of their lives. But at some point, probably within the first year, we don't know exactly at what point, they cannot switch them anymore. So when you take a coral from a hot reef, they usually have symbionts that are adapted to higher temperatures, and put them in cold water, and vice versa. Corals from colder water, same species, but that harbor different symbionts, and put them in hot water. They cannot switch their symbionts. They will not be adjusted to this different temperature. But of course, we grow them up under the standard temperatures that reefers have at their home. So they don't come from maybe Indonesia, where they're actually used to warmer waters, and where maybe if you keep them colder, they are a little bit stressed, and vice versa. So we keep them at the standard temperature, and we offer them different kinds of symbionts that we know work in this kind of temperatures, and they pick them up and they grow really well. And this is just one mechanism we know of, and we know that there's a lot more mechanisms to it. The genome of the coral is so much bigger at the beginning, and then basically when they grow up, some of the parts get clogged basically, and they can't reactivate it later on. So when they learn as a juvenile, I don't need this ability where I grow up right now, then they forget about it. And when you take a coral from the reef, it won't be able to do that anymore. But when you grow them up under aquarium conditions, it's a completely different story. And it is really, that has been the biggest joy over the past month, really, to see that in people's aquaria, because we really believed it would be true, but of course we didn't know. So now that these corals are in people's aquaria, and it's crazy. Like some people told us the other day, like the tank kind of crashed, like all SPS died, all of them, except one of our Acropora kentai, who's just growing like crazy. And it's just thriving. I mean, they are mortal.
Yeah.
For
If
sure,
you
but you can't compare it
intend
to
to kill them, you will succeed. I can tell you that for sure.
Yeah, I suppose we see it even with, like, certainly from other hobbyists, frags that you might be given or purchased from other hobbyists. You see there a different level of hardiness, if you like. So I can only imagine if something's been spawned and been in captivity, if you like, its entire life.
Exactly, and that also ecologically makes a lot of sense, because if you think that every last corner of the tropical Pacific has been colonized by coral, and they get drifted away as larvae for thousands and thousands of miles, right?
Yeah, very true.
And then they settle on some volcanic new island or shipwreck or what have you, and the likeliness of the conditions there being the same as in the parental reef is not too high, so they have to have this
ability to adjust to.
Exactly, that inert ability to adapt to colonize these vast biogeographical regions. That is also one aspect we think is really key for restoration purposes, right? To like support reefs through sexual reproduction, to bring out vast numbers of spawned baby corals,
to have the genetic diversity, and also for them to be able to adjust to the slightly higher temperatures that we already have.
And you can also kind of future-proof them, which is kind of
well, maybe
but you could rear them for like half a year or a year under elevated temperatures, give them certain symbionts, and then they may have the ability to
deal with
what's coming.
So we've got a few questions popped in. Rama is asking, good evening, Rama.
Hello.
Were these pictures taken with an orange filter?
No, like 99% of the pictures I take are not taken with any filter. I only adjust the white balance. I try to always make them look exact or as close to as I see it with my bare eye. I do have problems though with like getting the green and the blue, like the color that is in here now in the middle on the left. The tips are really blue and not quite purple. But when I adjust the white balance, so it's blue, the green will just look washed out. So I still struggle a little bit with it. But I do not use orange, like really rarely use orange filters. Only when it makes them look more realistic then.
Yeah, the interesting thing is that a lot of the Kentai have a lot of blue, how would you say, nuances, like blue, turquoise, purple. And under daylight conditions, that it's really popping.
It looks cooler than, like, better than on the only blue light.
Yeah. Perfect. We've got a few people joined us as well. Billy's Reef is with us tonight. Good evening. Gaza is with us as well. Good evening, Gaza.
How are you doing?
Good afternoon, Emma, over in the States. You're doing well. Good evening, Immers.
So many people.
How's it going?
More people coming. And then we've got a couple more questions. Mike is asking, do you have any concrete evidence to suggest that pH is a significant driver for health?
I mean, what like as a scientist, what is?
I will keep his hands down.
Yeah. Sorry. I'm sorry for the scratchy noises.
It's actually since you've moved your microphone, it isn't bad now. So don't worry about it. Yeah.
That is kind of a genetic, imbalance. So pH swings, I think, shouldn't be too large and shouldn't go too far down overnight. That I've noticed over the years, especially in acro. So we try to keep the swings not as pronounced. And one way we're doing it, so the way we run our system is the classic bulling system. So we use, of course, mostly Tropic Marine products, Tropic Marine, the Pro Reef Salt, and the bulling system. But at night, because the systems are really heavily stocked, some of them, they draw about like 3 to 3.5 DKH per day. So there's a lot of biomass, and they all they breathe at night, unfortunately. So they exhale a lot of CO2 that would bring down your pH quite a bit. So like years ago, we were doing Kalkwasser dosing at night, but in some systems I would have to run like between 40 and 50 liters of Kalkwasser per night. So that is then quite a bit of effort. So we switched to sodium hydroxide. So that is sodium lye. Basically, we dose that at night to kind of buffer the pH more. And the goal is to catch all the exhaled CO2. And the nice thing is you can kind of recycle it into carbonate. So by dosing the sodium lye at night, I can recycle the CO2 into carbonate, and that can be then used again for as alkalinity. So that saves in some systems it's up to half of the daily alkalinity dosing that we compensate by the nightly dosing.
So we definitely do something against pH drops, but we don't obsessively like monitor it. Like we really rarely measure it actually.
So looping back to the initial question, like in my experience, if it drops significantly below 8 at night, the corals are more susceptible to bacterial issues, I would say. So we try to keep it to not drop below 8 at night.
Yeah. Good. That's I can put a tick in the box there. I think mine's swinging between 8 and 8.3.
Yeah.
So yeah. Okay. Good. And then Mo's got a question, and I'm going to ask. I was kind of going to come on to this a bit later, but I think we could probably talk about this now. So what I'll do is I'll put the question up, and I'll bring us back and get rid of the corals off the screen at the moment. Mo is asking, how do we get these in the UK?
Yeah, so currently we're working on our first non-EU exports that are the first country we're planning to export to is Switzerland, and also the US we're working on. We're in close contact with our authorities, and which is really interesting because for them it's also a very new situation, and CITES listed species that is reproducing in that way with that vast amount of offspring initially, and then numbers reduce vastly. How like the German regulations are a bit dated, I would say, so we have to fit everything into the regulations. So
they're very nice and helpful, but basically the first CITES it takes a couple of weeks, months to get through this process. And once they have checked everything and we have a system, then like getting export CITES should be much faster. So basically when we have that, at some point we would be able to bring them to you guys as well.
Yeah. So if the demand is there, and
let us know. If you want
some,
we can find a way.
Yeah. I think there will. I think the problem for us is the marine hobby in the UK is really small compared to the US. You know, from a business side of things, you're far better off putting the effort into achieving it to the US. And you know, we see this in everything. All of the imports, the US get the pick of what they want, and then we get what's left. You know, it's just the way it is.
You're still ahead of Switzerland, according to what I hear. So, our Swiss colleagues are.
They're pretty happy that we want to export to them.
Yeah. Usually they are like within Europe, they are not the first pick. So for us, they're going to be the first ones.
Excellent. Right, let me flick back to that view. Yep. Okay. I had some questions. Can I zoom in? So I did zoom in on them while we were talking previously. There's some people that are trying to watch on a phone, so yeah, they struggled a little bit.
Yeah, you can see like a lot of like if you check our Instagram, this is really where most of our pictures are. Like our website is still very, very basic. Don't try to find anything there, but on Instagram I put up pictures every day.
Yeah, we have a website, but that is all I want to say about it.
Work in progress. Work in progress.
That was where we got to, wasn't it? So let's carry on going through these. So we had the grade 3 was the highest grade, you said.
The highest grade
for the uniques.
And the 4 is the highest.
And then 4 is the chimeras. But the 3 is basically, I put very few in that category that I think are just perfect, that have very vibrant colors and the perfect shape.
And just for the people that don't know, the chimeras are going to be a blend of 2 different species.
So you have a colony that is comprised of multiple different individuals. So if you would do genetic testing on the green part, on the blue part, or whichever color, you would find out that it's 2 different animals.
But they are able to fuse. So especially with acros, they seem to be only able to do that very early on after settlement. So it's a kind of immune system thing. So their immune system can accept their neighbor as them, basically. They don't recognize it as something other. And once they recognize that early on, they can, not always, often they do not, but sometimes they can fuse and become these gorgeous.
So that really is going to be quite a new side and a new thing to bring to the hobby. I can't imagine
you can only produce them in that kind of way. So once, like within that I want to say window or time frame, if they have contact and fuse, they kind of become partners. And once they became that and fuse, they stay that for life. Basically, but after it depends a bit on the species. Like the Kentai have a bit larger range or time frame in our experience. Other species like Millipora, the time frame is much narrower. So if they don't fuse within that time frame after settlement, they will fight, and one will overgrow the other one.
So you can find them in nature as well, but it's very, very rare. So sometimes you can find a chimeric coral on the reef, and of course sometimes finds its way into the hobby. And but it's not common.
Yeah, but it's also interesting in nature. So point A, why it's so uncommon, is that the larvae are dispersed over vast areas.
Sure.
The likeliness of 2 conspecifics settling that closely together that they can fuse within the first month.
A lot less than in a
lot less than if we settle them on a higher density. But we've seen that on Guam as well. If there is like a heat wave event in the summer and you go diving or snorkeling in the reef, and then you have a big colony of, let's say, Acropora, Circulosa, or Digitifera, like different ones, and you see one half of it is completely bleached. I mean, there's still tissue and polyps out and whatnot, but it's fully bleached, and the other side is perfectly fine, right? And then okay, that one is a fused colony, that's a chimera, and the one side is, for whatever reason,
better adapted.
Yeah, it's better adapted, like genetically, or took up, I don't know, other symbionts or whatever, but the one side is fine and the other one is not.
What other ones do we have in here? So we've seen the grade 3, 2, 1 of the uniques there.
Yeah.
What do we have in this one?
Austera. This is again the Austera where the parents were completely green. And with those, you have like sometimes very pronounced pink and yellow tips, and sometimes the yellow tips make these beautiful swirls, I think.
Yeah, those like fusions are so cool.
Yeah.
Wow.
That is just
so how big is that?
That coral is about this big, I would say. Yeah.
What, the bigger one of the 2?
Yeah, the bigger one. The bigger one of the 2.
I mean, it's the same, but after 8 months, So that's also I mean,
And that was moving in between and stuff. It was not trying
the
to.
power of youth, you might call it, because they grow really.
Yeah, so the ones that are 15 months old, the biggest ones are about this big now.
Yeah.
So they were a little bit over a year ago, they were just one cell. So they double, like now still every 2 months, they double in size for sure.
Yeah.
Like they grow really, really fast. So even when you get like a smaller twin, like a small frag, like they will become bigger colonies pretty soon.
Wow. Yeah, that's what else we got. So these are some shots of the different types. We kind of talked about this.
Yeah, we
So
already
this
talked
is how
about
you
it.
get to your twins.
Yeah, so
Yeah,
these are the
exactly.
parents on the left, and on the right, these are actually photos of the parents, and then the juveniles have these completely different colors, and then we take frags of these, and these
That's
are
a
the-
really nice little illustration there. I like that.
Thank you.
Top left is Hannes and top right is Claude. So we got that really nice concoction of the Natural History Museum and Fauna Marine.
Yeah. Yeah, you can see the one on the left here. You can see some slight
Yeah, exactly.
coloration on
That
the
one
tips,
has a
can't you?
little bit of it. Yeah, just a little bit.
Yeah. But then when you look at the difference with the
Yeah,
offspring
it's
is
like, yeah. Wow.
huge.
Nice.
Yeah, and these are the tips you were talking about with the kind of like marbling effect.
Mhm.
Yeah, stunning.
Yeah, this is just a little video. Yeah, this is just some of the Nasuta with the fine branches, and they get these when they grow well. They get these really pretty pink growth tips.
Yeah.
So with the freshly cut frags, of course, you don't see the pink tips, but they will come once they grow
Yeah,
well.
initially after fragging, they go into growth of like the basal discs.
Yeah.
And then the growth tips are not as vibrant, but once they covered all the area they can cover and feel more safe, then they will go into branching again.
Yeah. So what do we have here?
Well, we have
That's an interesting one.
Yeah.
Can you guess?
Yeah.
Anybody?
Can anyone guess? These should be ready by, I would say, fall or end of the year.
So it's a juvenile coral. It's
I'm guessing this is a
old.
very small coral at the moment. This is very
but
zoomed in.
It's a couple of months old by that time. The photo.
Yeah.
Okay.
Blimey.
Yeah, by now they're quite a bit larger. I mean, the acros is what we started with, what we did most of our research with, what we got the most experience with. So that was like the initial. But there's so many beautiful, amazing scleractinian species out there, and then we thought, you have to branch out a bit.
Yeah, so acros is also where the science knows most about when it comes to spawning.
Yeah.
A lot of scientists work with it. We've worked with it, but it is challenging. Even when we go from one species to the other, there is so much we have to learn, and so much, things that can go wrong and that do go wrong all the time still with us. So we were a bit hesitant, but of course we said, okay, of course we need to go into the LPS. This is where the bans are. This is where also overfishing has been taking place already with these guys. So these are actually the ones that you can't frag, where this kind of reproduction would make the most sense.
Yeah, and that you can't import anymore.
Yeah, and that also, I mean, you guys had the ban for a little while longer, but also in the EU, there is a ban on different LPS species now. And so we got a couple right before it closed down for them. And we were lucky with the Trachyphilia, actually. So we have
okay.
now.
Wow.
Yeah, these
So
are
they're not
trachyes.
they're not really ready for the market yet, but by end of the year we will have Trachyphilia too.
Wow. I was
So
way
we
off.
now
Way off.
expanded the biggest ones as of today, I would say, are across 1 centimeter.
Yeah. My head was saying, as it is right there, it looks a little bit like a blastomusa.
Uh-huh.
But Yeah.
Yeah,
And-
they look so different, like, but that will be so exciting. Like, and so you can see, I mean, they're just brown right now, and they have a little bit of this cool fluorescence, so that's
The
already
fluorescence
interesting.
is picking up a lot
But
now,
the other colors, they're not showing it all yet. And that's also the same with the acros. It's very different from like when you can see the colors. Luckily, with the tenues and the kentai, you can see it. You can start seeing it after like 3 to 5 months. You can start to
Yeah.
see the colors, and by the time they're like 6 to 9 months, I think you can pretty much see what color they will have in the end. But yeah, with acros like the millipora, same age as the kentai, they're like 15 months old now, and they're like just starting to show as well.
Yeah, they take a bit longer. So a millipora, initially they look like what's that? Like Briareum.
Yeah, they look
What's
really
the
ugly in the
English name?
beginning.
I mean, the green is nice. So they're like green, the long tentacles, like carpet building, and then they turn brown. And then nothing happens. They cover as much area as they can possibly get, and then after I don't know a long time, then they start branching, and then
they get the colors.
then they get the coloration.
Wow.
Yeah.
It's so different even within the acro. So that's pretty funny. Also, microclados we have in the pipeline, and they
Wow.
also take a bit of more time to express coloration. But yeah, with the LPS, we're now we were lucky to get enough broodstock of different genera. So we got the trachees, with which we had success now, and have quite a few in the pipeline. We got scolies, which hopefully next season we'll be able to produce. We got the acanthophilia, got some quite nice, big ones.
Very nice.
Yeah.
So I was actually quite excited. I was at the TMC premises yesterday, and I got chatting with Brian, the CEO there, and he kind of just dropped a bit of a nugget, which is now kind of announced. It was kind of almost announced at the time, I think, but they've been speaking with CITES about the reasoning why we had some banned corals that we had that maybe weren't banned elsewhere, and now that we're not part of the EU anymore, we were kind of saying, well, do we know why they were banned, and can we do some research into this? So they actually funded some studies, and let me put my presentation way back to this one. Wild Indonesian acanthophilia and trachophilia are now allowed to be imported back into the UK. So just like,
wow, that is exciting for you guys, huh?
Deshies can come back.
Nice.
So they're banned in 2021. So I've had 5 years without them.
A long time.
Yeah. Really, really excited to see what might be coming.
I always tell the story, Steve, of the bleeding apple it was something like 150 or 200 pounds or something for a coral. No, and I think, Christ, if I'd got a couple of them back in the day, it'd be worth a little bit now.
Oh, that's exciting news.
Yes, so that's just one of the pieces of news that we've got. But yeah, it just fitted quite well what you're talking about with the acanthophilia and trachees and everything.
Yeah, with the trachees, one thing we're also like to go back to the loop, do the loop back to the adaptability of the juveniles, because a lot of the trachees that came into the EU or Germany were usually sourced from Australia, like Southern Australia. And like in their winter time, they go down to like 18 Celsius, right? So in their winter at them at 18, it was even unpleasant to put your hand in there, right? There was like the water condensing outside on the glass and all that. So I think a lot of the main issue that people had with them is they were toasting them for too long. Right, so 25 is their top summer temperature, but if
They
you
don't
put
like it very much.
yeah, but if you put them in a like standard tank at like 24, 25 Celsius for like forever, then after a year they start to do not too well, and then not open anymore and shrink and shrink and shrink and so on. I think the wild ones, they need this. I mean, as we know from like terrariums, like different amphibians and reptilians, they need their cool phases or plants. I mean, that's part of their system, right?
Yeah,
So
we don't know if they need this or just like a little bit lower temperature.
Or a bit lower,
general.
but I'm very sure that has been an issue. So the offspring that we have now, we don't do the seasonality with. So we just rear them at the standard 25 centigrade, and they should be much more, aquarium ready than the imported ones.
Yeah. Okay. Well, that fits quite nicely with this question that Matt asked. Do you think that using your corals to repopulate coral numbers in the wild would be a benefit with the resilience? Yeah. Do you think there's like a thermal resilience building up in these corals?
So we will never put out corals that we produce here in Germany somewhere in the wild. That would be like, there's like legal issues, and ecologically, I mean, we have corals from a lot of different regions and all kinds of things mixing. Like these should go into aquaria, but not in the wild. But of course, using these kind of methods that we and others are developing to restore reefs with sexually produced juveniles makes a lot of sense. And also maybe to rear them at a little bit higher temperatures for a couple of months, and giving them different symbionts or having them pick up symbionts that are better adjusted to higher temperatures, that might very, very much make sense. Like producing corals sexually for sure, and maybe even rearing them in some kind of aquarium facility could really make sense, I think.
So are there cases of you all sort of talking to one another and I suppose somewhat working with one another? Because Jamie Craggs in London might discover something that is so beneficial to yourselves, to a farm in Indonesia that's trying to repopulate a reef and things like that. Do you find there's a lot of conversation between you all? Or do you wish there was more of
We've
that?
known Jamie since 2015, 13 even. Yeah, so we met
yeah.
Jamie a while back on Guam. For coral spawning work, of course. So yeah, we've known him really, really well, and our paths have crossed a bunch of times over the years.
Yeah, I mean,
and,
our first XC2 spawning facility was built by his company.
By his company, yeah.
Yes, yeah.
So yeah, so no, we definitely talk. Maybe there are some secrets everybody keeps for themselves for a little while, for sure. But much is shared, and especially when it comes to reef restoration.
Yes.
I think we're all, there's not that many people that do this really. And everybody has a great passion for coral reefs, and this is also really where we come from. Of course, we love aquariums, but we love coral reefs more, we have to say. And this was really, we saw the coral reefs dying. And of course, the global warming is the biggest, by far the biggest factor that have our reefs dying. But the two of us cannot do much about this. But we can bring a lot of change into the aquarius market. So that's really where we saw, okay, maybe like we have this ability to breed corals this way, and we could really turn stuff around there and make things more sustainable, maybe. Yeah. So this is really our main motivation, we have to say.
Yeah, and then subsequently also support lights of our geckos went out. So I apologize for the darkness. Subsequently to support projects that do active reef restoration. So because at the moment we don't have the capacity to go abroad and do active reef restoration, but what we do is basically develop methods to produce in an efficient way as many corals as you can from eggs, and these methods then you can also apply in the countries of origin, even with a very low tech approach. So in Guam, we used mostly like salad bowls and the plastic tanks. So it was not very high tech approach. So you can do that with a very low budget if you know what you're doing. But at the same time, that will take a lot of time until we actually will be able to engage in that. So in the meantime, we thought it's also not great to do nothing. So we know a project in Eastern Africa, south of Zanzibar and Mafia Island. They are called Ropes of Hope, and they do a lot of restoration with like fragments, and we're supporting them. Now
so one of our colleagues from the university, she's working there, she's doing her PhD there, so they do really a lot of restoration work, actual restoration work, lots of hands-on work, and they also have scientists monitoring their efforts, so they can actually show the numbers that the things they're doing are working really well. And we really love the project, and so we're supporting them a little bit as much as we can right now.
In the meantime, or in the not too distant future, they will also incorporate the sexual reproduction into their means of coral production.
So our goal for sure is basically to be able to say someday, when you buy a coral from SciReef, 1 or 5 or whatever get planted out in the reef. So this is really where we want to be at.
I do wish there was more understanding from the non-aquarist, the person that isn't keeping a reef tank, of that relationship between a lot of hobbyists and reef restoration. Because I know when I talk to people that aren't sort of in the hobby, and I say, I keep coral in my home, they may even ask, is that taken from the ocean? And immediately it's got this negative connotation associated with it. And I think without the lights that the hobby has brought, without skimmers, without so on and so forth, what you're doing just would be so much more difficult and so much harder.
We would not be able to do this. We would not be able to do this without the knowledge from the hobbyists. And that was really why we were able to do it in the first place, because Sam was a hobbyist before. Like, honestly, I mean, we came into the science world and like, most scientists don't know how to keep a coral healthy. even like coral scientists, they don't know how to keep a coral alive in a tank. They just don't know. You don't learn it. And
there's several aspects, I think. So one, the negative connotation I don't feel and get from like the outside world every now and then as well. But I have to say, anyone who is so fascinated by coral reefs that they go through the efforts to put up an actual coral reef in their home and go through the financial aspects, of course, and like you have to know about physics, chemistry, biology, everything, like all disciplines you have to kind of like conquer. So you have to put a lot of effort in, right? So anyone who is fascinated in a way to be able to, or to be motivated to put up with, I mean, they don't really want to impact the reefs in a negative way, right? That doesn't make sense. Right? Of course, the trade has its certain dark sides, of course. There's things that can be optimized as well, but it's not the incentive of the hobbyist to like do any damage to the natural reefs, right? That doesn't add up. Right, and then for science, like what I thought was kind of peculiar, but it also makes sense that there's this discrepancy between the scientific coral research and then the hobbyist world, and that these two worlds are kind of separate bubbles, that there's not too much overlap in it. Because I mean, I've seen things being conducted that we don't need to talk about that on that platform, but it's kind of puzzling to see like the lack of a grasp on how to run a reef ecosystem
Yeah,
like
so
the
it's basically when
recirculation.
aquarists and scientists talk to each other, they kind of leave the conversation both thinking they don't know what they're talking about. They're both right.
Yeah.
But of course, they're both wrong as well, because
Sure.
both sides know so much. But they can't, like, as many scientists, they couldn't tell you the basic water parameters that are in the ocean. They couldn't tell you that. And for aquarists, it's like, how do you not know, like, what
Yeah.
pH it is, like what?
Of course, you guys are sort of living proof that when those two
Yeah.
communities do come together,
So
Yeah.
amazing things can happen.
trinity or that overlap, that is
Yeah.
pretty rare, and I think there's so much potential for
Yes.
things to be done, projects, and also for protection of the reefs if these two worlds would merge a bit more. But often, like, there's a bit of a clash. But
but sometimes also for us it's hard, because like sometimes even working with scientists, they don't appreciate how much work and effort it has to go into like keeping corals happy, and like, for example, also doing experiments, like long-term experiments with corals, like how much effort that is, because they just put them in water and like put a air stone in it and they'll be fine, right? And it's like, no, you can't do an experiment like this. And sometimes it's a bit frustrating.
Every coral research facility needs like a volunteer aquarist to go and work there.
One thing that often is not, people don't grasp, is like the experience you gain as a hobbyist, right? You spend like if you do it decades, you spend tens of thousands of hours looking at coral, right? And you see like the tiniest changes in tissue and polyp expansion and what have you, and the overlap it with the water chemistry, right? So at university, you don't have tens of thousands of hours to stare at a tank, right? So that is
sometimes
that is
even
lacking.
the most simple. I mean, maybe one anecdote. Recently, a scientist asked us if our corals, why they are so bleached, if like the temperatures are too high, or if there is like some chemicals in the water, and he was just referring to like the pale growth tips. The coral was really, really healthy, and it was just really growing really well. So the tips were white, and they thought they were bleaching. So just like that was just the point where it's like, scientist, coral scientist.
And then I have one nice that like my urchin anecdote. That is like, that was like in 2010 or 11 on Guam. We had a colleague doing feeding experiments with diadema urchins, right? So they were offering them different kinds of food to see which ones they preferred. So they collected the urchins, and then they were like, hey, they're dying after a week or two. I have no idea what's happening. And then it turned out, so they collected them, they put them in the holding tanks, like full blast sun into it, no nothing to hide under, no shaded areas. And when they wanted to do the experiments, right, they took a barbecue spatula and just scraped them off and kind of razored off all their tiny little poor feet, right, and put them in the feeding tank, and then put them back, and then after a couple of days they died.
And they didn't know why.
They just cut off all their feet repeatedly.
Wow.
Well, we showed them how to handle diadema without getting hurt and without hurting the animal, and suddenly the experiments worked well.
So that's kind of sometimes peculiar, like the lack of.
So if we're ever studied by an alien race, I hope the one that studies me is one that also keeps humans for a hobby, so they know not to tear my feet off or something.
Oh my God. That is hilarious. Yes.
He's sitting on the couch again. Cut him off. Scissors.
Brilliant. Right. Anyway, let's get back to some pictures.
This is one of the tenuous babies. So the parents look completely normal, like tenuous, and then some of the juveniles we got look completely like tenuous, and then some have these, we call them long fingers.
Yeah.
Yeah.
Wow.
So there's really a gradient in morphology, and they have grown up all under the same conditions, same light, same current, or same flow, same nutrients, same everything.
Wow.
And some have this really tubular corallites.
Yeah. So they have these like colony shape that is kind of like tenuous, but then these really
So
long
our current
axial corals.
hypothesis is that the parents that we got have been hybrids of tenuous and echinata.
Yeah.
Looking like tenuous. So and if you cross these, then in the next generation, you get a distribution of the traits, meaning that some of the offspring have much more tenuous-like genetics, some are intermediate, and some are more echinata-like. And then you have this gradient of morphologies in the following generation, and that's what we guess is producing these different morphologies. So we have taken genetic samples of all of these and have handed them to
coral geneticist.
The coral geneticist also here at the University of Oldenburg. And it has been a while, but we're still confident that someday we'll
get answers.
We'll get the actual data. And then we should know for sure, hopefully.
Yeah, that just looks so different to what you would expect.
Yeah, it's crazy.
Yeah,
that's another one of those.
Another similar,
Yeah.
And then I think the next picture probably can't see it right, but then the next picture is their sibling. So it has short axial coralites, completely more like
totally different,
much more
totally
stocky,
different color, completely different ghost shape. It's their sibling, their direct sibling.
Crazy.
Like,
Yeah.
so that's sometimes when people go into like, oh, but I don't think it's that species because the coralite form is just slightly more rounded. And then I look at them, they are siblings. These two are siblings. Like, I don't even want to try.
Yeah, I mean, I struggle at the best of times with identifying sometimes identifying some of the different corals. Now I'm not even sure I'm going to try again.
I'm pretty confident identifying corals to a genus level, like that I'm pretty confident at, but with species, it's like more of a guessing game for me.
It's almost like the more you know, the more difficult that then becomes.
Yeah, and also the genus Acropora is under revision at the moment. I mean, even the tenuous group has been split up into like 6 or 8 species, right? The tenuous from Australia is now Kintai, and the ones from Indonesia is Bifaria. The actual tenuous is just in Fiji and Tonga, I think. Then there's one in Okinawa that got a new name. And I think
even when you speak with like the actual scientists who like are experts in coral identification, like they all have different ideas of like how corals in a certain region should be named. And of course, that's the official way it is right now, but that is not true at all.
That makes me feel better.
And it's likely that we'll end up with like beyond 500 different species of acros in the not too distant future.
So I think it's amiable to try to be good at acro identification, but that's just nice. That's the same one. I fragmented it under UV. They have this green fluorescence.
Yeah. Really
it's also a sibling of the one with the long coralites.
Wow.
I think the next pictures, that's just with normal white light, and
daylight.
Then the next one is a frag of the long finger, the sibling. And then
that's just so crazy how different they are.
Yes. So it is you cannot imagine how exciting it is to see these juvenile corals grow and to see what comes of it. I don't know. It's so much fun.
But in the first month, I mean, the initial step is you want to take them up the Zooxanthellae, right? And they're brown. And they're tiny little tentacle
Yeah, so
creatures
the first ones are usually not fun.
that are fully brown. That's exactly what they should look like. So, and then after the first spawning in the new facility, we had visitors come, and we had the tanks full of the settlement plates, and they're all covered in the tiny corals. And we're like, oh, that's the Cropper Kentai. They're going to be fantastic, probably. I mean, we had no idea how they would turn out, right? And then people
We're
would
so
look
proud.
in,
And
like,
everybody-
are these tiny brown thing? Are you sure that's not Hyptasia?
we were like the proudest parents. Like, look at how pretty they are, these little brown things. Yeah, that's just the same individual under blue light.
Yeah. Okay.
Yeah, so these pictures are not in order. That's just again the Austera.
Very nice.
I sent you a lot of Austera pictures, I guess.
Yeah.
They're fun to
Yeah,
take pictures of.
We don't mind.
Yeah,
Wow.
the Austera really grows fast.
Yeah.
That's
Yeah, and
pretty,
that kind of marbling effect
Yeah.
on the
it's
tips
so
is
cool.
really interesting as well.
Yeah. Oh, yeah, that's just sibling of the Austera and fluorescent. They don't have.
plain green.
And another sibling.
Mm.
Yeah, you see, I would say if anyone asked me, I would like, yeah, they're definitely two different corals.
Yeah, totally.
Yeah.
Wow.
Ah, yeah, it's one with more fluorescent.
Yeah, I think that one was
Traits.
taken with a filter.
Yeah.
Yeah, it
Yeah.
looks like it.
Yeah, that is one of the very few that was taken with a filter.
Yeah. Okay. Right. Let me move away from that view and then just come out of there, because I think that might have been. Was that all of them? No, there is more. I was about to say, I thought I had more. So let me go to here.
Hi.
So these are now the really, really special ones.
Yeah, so this is a chimera, and you can see that the one side of the colony is blue,
Mm.
and the other side of the colony is like really pale pink with green fluorescence and yellow
And-
tips.
Some are both.
Yeah.
And then,
Yeah,
yeah,
there's a cool
in
little
the middle,
part in
you
there.
can totally see this coral has fused, and in the middle part, branches grow up to be both. And you can also see marbling, but here it is really
Wow.
composed of two different genetics. So you have the blue genetics and the yellow, pale green genetic, and yeah, it fuses and it marbles. And the more they grow, the more they show this these splice branches with two colors. And yeah, that's really fun to look at.
Wow. Yeah. It's just crazy looking at those.
Yeah.
Yeah.
It's unlike anything I've ever seen.
Yeah, and it's
Really,
also
really
so fascinating to see them change over time. Like
Yeah.
in the beginning, we only had like a very few chimeras that had these splice branches. And then like over time, the more they grow, the more it shows
Mm.
up, and it's it's really beautiful.
Yeah, then initially when we started to sell, then we also had customers come over to pick out corals, and then also one of the customers, he found one the really nice chimera among the grade one.
Yeah. Yeah.
And then he also
Oh,
got
really?
it for the price of a grade one.
Yeah,
because
it's very
he-
likely
Oh,
when you
wow.
buy one of our coral, not very likely, but there is a chance that you get a chimera without paying for it, basically. So I still, even though I've looked at the same tanks, the same corals for such a long time, but sometimes like whoop, a different color branch shows up, and there was a different larvae in the game, and it didn't really show until like now. Like just
Mm.
like last week, I found two chimeras among the grade 2.
Wow. Wow. Yeah. So if you're going to pick them out, make sure you have a good look at them. See if you can get a bargain.
Yeah.
At the Reef Mania, we hit one.
At the expo, Mareen hit one of the chimera.
Yeah, we had like one really small chimera, and we put them among the twins, so among the frags. So, and at some point, we put them in between, and I posted it online. I was like, okay, there's a little Easter egg for you guys there. And someone phoned it right away, and she was so happy.
So it took like 15 minutes. It was gone.
Wow. That's really cool of you to do that. That's cool.
Yeah.
Oh, look at that.
Yeah, you can really just. It looks like when I've had the shutter speed set wrong on my camera, and it kind of stops and it gets that shutter effect where you get two different types of light. It looks like that, doesn't it? It's crazy how you can really see the lines of coloration in the coral.
Yeah.
Wow.
Nice.
Oh, that's one with the purple.
Yeah, that one is no longer with us. That one.
Ah, yeah. Oh, yeah. That has found a new home.
Yeah.
I thought there was going to be some story about how you'd killed it then.
No. We haven't killed anyone. Like none of these died. Like
okay.
Yeah,
Good.
no,
Wow.
no, seriously. Like only corals that died in the tank where we have the Kenti are like the mini micro frags that we did that were really, really tiny. And then we once had an accident with a lot of fresh water coming in. Somebody forgot to turn the fresh water off, and then like 10 of the 300 corals that were in there died. So but the rest, no, they're pretty sturdy.
Yeah, you can do a lot of things with them.
Yeah.
There's just a small one. You can already see.
Almost looks like a gonid.
Yes.
No, it's just like I don't know exactly how old it is. Maybe 5 months, maybe.
Yeah,
so it's a small. Yeah, it's a small one, but you can see the green side and the blue side.
Yeah.
So once these colors start coming in, and it's very exciting to look at these tiny little ones and imagine how they grow out.
The Kentai starts at about 3 months to 3-4 months to get the first coloration or the first hints of what kind of color they're gonna express when they're about like almost a centimeter. That's then when they stop being just brown.
And we were pretty excited. We thought that we would have quite a few of like maybe brown corals in there. I mean, we knew we would get like some variants, and we thought, okay, maybe like 20% will just be like not attractive at all. And that's not the case. Like even the ugliest ones, they're like completely turquoise with like pink tips or something. Like there are like, we're pretty lucky.
That's one
of the biggest chimeras I think we have. It has a lot of spice branches and it's big.
So who's the photographer? Who's the main photographer here?
Yeah, it's only me.
Wow.
I know I can still learn a lot, but I'm trying.
Well, I was going to say, can you give us some of your tips, because they look phenomenal.
So I use the Olympus TG7. I don't know. It's like a small, very small compact camera.
Waterproof.
It's waterproof. So I just dunk it as it is in the tank and photograph with it. So we've been using this kind of camera for a really long time because it has an amazing macroscope mode. So you can just like free-handed take extremely good close macros, like also the small corals. I photograph everything with this camera free-handed. So that's extremely handy. Even we check on our embryos, they are like 0.5 millimeter, and we can take free-handed photos with this camera and check on the development of the eggs with it. And amazing. Like they're like $400 or something. They're not expensive cameras, and
I would say it's one of the only compact cameras that has a really good microscope mode
Yeah.
and is waterproof at
We're
the same
not
time.
camera experts whatsoever, but I've been
Yeah.
using that camera and we've been happy with it. So
Yeah. Yeah, that is good. I was not expecting you to say that at all.
thank you.
Yeah.
Well,
Look at that.
Yeah, so that's in the tank. So yeah, I mean, we have, of course, a lot of corals in the tank. When you want to take pictures individually, you can't take a picture from outside. And I also don't have the time to, at first, I always set up like a photo tank and like put the corals in there, but then you would have to wait for half an hour for the polyps to open up again. And it would take me like half a day to photograph 5 corals. Like, I cannot, like, yeah, no, that's not possible. It's not efficient.
Yeah.
I don't have that much time to take photos like this. So now I just like dunk the camera in the tank and then I cut out all the outside later on digitally, and if I need to, if I want just black background. And
Yeah. Wow.
and yeah, I usually never use a filter. I haven't really found a filter I'm happy with. I don't know, like,
Yeah.
I think it just always takes the glow away, kind of. I don't know, it's hard to describe. Like, I tried, like, when I do the settings with just the white balance, they usually turn out a little bit better than with the did our son just wake up?
I think our son just woke up.
I will take the microphone and he will check on our son. Sorry. Yeah, so I don't know. I try to experiment more with filters, but I tried a couple of things and I always found just the white balance was just a little bit better.
Yeah.
Yeah.
Yeah, I've tried lots of different things. I actually had quite a bit of success. I went to a coral show and I didn't have, so I had a lens for my phone so I could take pictures, but I didn't have one for my camera. And one of the guys on one of the stands had some orange acrylic that they just used as a divider in one of their tanks.
Really?
And he took it out, dried it off, and gave it to me. And I just walked around with this bit of orange plastic that I just held in front of my camera, and it did an amazing job.
No way! Oh, that's
so I've still
cool.
got a piece of that in my drawer that I sometimes use when I'm taking
Send me a
pictures.
piece. No,
I think that's
actually,
where the orange filters come in like handy, is somewhere like a show where you've not got control of the lighting, and most of the time they are super blue to show off the most fluorescence. Whereas at home, I think we're all trending kind of a bit more white light anyway. And as you say, just adjusting white balance generally can get you a nicer image, and there's nothing in front of the camera to kind of optically affect the quality.
Yeah. Corey, I don't know if you know Corey Coralhead from he recommended me one filter and he actually lent me his to try it out, and that was the best one I was able to find so far, but they don't have the size I need for my camera. So back to zero.
The Tiffin one is quite good. It's available on Amazon. Tiffin, I can't think of the number, but yeah, there's one on Amazon that's Tiffin. I'll find it.
I will write that down right away.
I've got one right here that I use on mine, and I think it's probably the same. Yes, it is the Tiffin, and I'm getting to that age where I need a light to be able to read it. It is the 85B.
85B, okay.
Which is, if I put that in front of the camera, there. It's closer to yellow than orange, so
and it's not
it doesn't.
Very dark, is it?
No,
I feel like it's
so
not.
It doesn't
heavily tinted, is it?
Yeah. So it doesn't impact it. The more blue you use, the more orange you need to go from yellow. I've found, but this kind of is quite a good all rounder, I think.
I've bought so many lenses, UV lenses, ND filter. It's going to take me an age to find it. I'll find it in the green room, but I think it might.
There is it on some white background, so it is a bit of an orange.
Yeah,
quite a light orange.
Interesting. Yeah, I have to try more for sure, but I'm very
I mean,
pleased that you complimented my
they look
photo.
fantastic.
It means a lot.
But they do look fantastic.
Yeah.
I was not expecting you to say that you're using like a little waterproof Olympus camera at all.
Yeah, I think it's such a handy tool, and it's used by a lot of scientists I know, but I haven't seen many aquarists use them, and they're so handy. Like, especially when you don't
Yes.
want to invest a lot of money into photo setup. I think it's a really good camera to use.
For sure.
Yes, I will
Olympus, if you
certainly
want
be
to
looking.
sponsor us, we're open.
Yeah, I'm definitely going to be looking at Olympus waterproof cameras now. Then I'm
Oh, yeah,
clicking
there's still a lot of photos. Maybe you can go through them with
because
the
I'm sharing my screen. I keep clicking on the wrong screen. I need to click over here.
Yeah.
Wow.
More. They're also different, right? That's
Very
also
similar.
fascinating. They're like, I
Yeah.
mean, they're all unique corals, but like with the chimeras, they all look so different.
Wow.
It's a question there from Mike about the light spectrum, which would be interesting to hear about.
Yes.
The light spectrum. So we have pretty much a really broad spectrum. Sam is going back to explain it better. But yeah, we don't use like all blue light or anything. But
Little
we have.
one is back asleep.
Yes, you're right on time for.
So
question.
right now we're using mostly a light that is not on the market yet. So it's by B Specs or B Ocean. The newest version is going to be released in April. It's called the Gravity, and it has a really wide spectrum. So especially in the UV is covered, in the blue, you have a wide range of wavelengths. My mic is here.
Well, I was just thinking to myself, I didn't see him click the microphone on, but his audio is really clear. How is that working?
Excellent. Yeah. So I'm more of a like natural light, daylight person, because also being in the reefs personally for many occasions, to see how the reef looks in nature, in actual daylight. That is like my appeal. I mean, I can totally understand if people go like the full blue spectrum to see what the kind of fluorescent colors the corals can produce and what nature has in store for these conditions. But generally, we are more on the daylight.
And we think it's a lot easier to check on the health of the coral. Like when somebody sends me a coral picture under blue light, I cannot tell for the life of me if this coral is happy or not. I really have difficulty seeing the small variances.
Yeah, the nuances, and especially the parts that you can't really, that aren't coral, like the sides of the coral, like on the base, and if there is some issues or whatever. So it's much more easy to see if you have a sufficient white light I want to say part in it.
Yeah, and to the par, we actually don't use very much, honestly. So kind of surprising, maybe even
not for all.
Yeah, not for all. Like it depends a bit on the species, but the kentai, for example, the tenuous, they don't need that much. Like they have 150 on the sides. It's more like 100 par. So it's center, not that much.
Yeah, center is like 250.
Yeah,
250,
so we notice like when it's less than 50, they're not as healthy anymore. But we have one little frag that fell down below all the other corals on the wreck, and I measured it gets 40 par, and it's thriving down there. So,
wow!
I keep updating some stories on Instagram about that little guy.
I suppose if they're spawned in captivity and that's where they're spawned, they're likely to be more
Yeah.
able to
Yeah,
adapt.
but there's definitely variants. Like we know that the millipora, they need more, and they can also deal with more. Like we have some of them
Sure.
under 600, and they grow fine, and they're so if you want to put them under more light, they do really well with it as
Yeah.
well. But
Yeah,
they don't need that
that's
much
fine.
to
Then they
well.
grow also more compact, and then just for the fun of it, at the university, at the institute, I put some of the tenuous offspring. They had a daily peak of more than 1500 par. So we had the Radeon G6
Wow.
that was like that much about the water surface on full blast, and the coral was basically on the surface. So, but the power bill goes through university at the institute. So I'm not going to do that at our facility. And yeah, it was more like experimental, but they took it really well. They grew very compact, like super high density of corallites, and they were just
Interesting.
doing,
really cool.
very very interesting what they can
So
put up with.
we try to use as little possible, but we definitely see like with the Ostra, they also grow fine with 150, but they
200.
Yeah, but they definitely like it better to get like 300 or something, or 200.
And for millipora, microclados, insignis, they like a bit more.
Yeah.
So if you have, let's say, a Fijian coral that you spawn in your facilities, does it then become a German coral because it's born in Germany?
It does. Yeah.
Okay.
Wow. Yeah.
Because the corals that now entered the trade here in Germany and the EU, they don't have a CITES number because they technically cannot have a CITES number.
Because they've never been imported anywhere.
Yeah, and they have never crossed a non-EU border that would require them to get a CITES number. So they technically, so we have
the only corals on the market that don't need CITES number.
Yeah, that cannot legally have one. So we have been in contact with authorities, and we have been in very close contact because we're right now working on the first export into non-EU markets. But the way we do it is, so we only do B2B sales. So we sell to local fish stores within Germany and the EU, and then they get a certificate of origin. Yeah, certificate of origin is the right expression. So it's like a document where we fill in when was the coral born. Like we sell, I don't know, X amount of corals of species A to customer XY, and then we fill out they were spawned on day this and that, and
the parents have the CITES numbers.
Exactly. Mother colony has the CITES numbers X, Y, and parent or father colony has.
So that's just what we give them, and that is
when they get that certificate of origin, and that is what is required at the moment. But once that they cross into non-EU countries, then they will need to get their own.
But they're still origin is Germany.
Yeah, that must confuse some people. You're filling out the form, country of origin, Germany.
But one aspect is that feeds into it is that all corals that are sold as SciReef corals from our facility are chipped. So every single coral has an NFC tag inside their plug. So the plugs we have specifically designed for us. They're made of PVC. So because it's a non-porous material, so nothing can kind of
so you can scrub it before you put it in your tank if you want to.
Yeah. So it's you can clean it nicely. You can, and since we thought we do everything new. We thought that the stalk or it's a stalk, I think, of the plug, like the pin that you always have to clip or kind of cut off. it's very annoying. We thought it would be nice if you could just unscrew it, right? So we designed it in a way that you can unscrew the stalk of the plug, and then you can put in the
and so they all
NFC
chip.
tag.
They have a little NFC tag in it, so it always says the species, when it was spawned, that it comes from us, of course, and then of course the grade, and when it's a unique coral, also the coloration. So if you buy a SciReef coral somewhere, you can really be sure it is what the retailer.
There's a gentleman here in the UK, Tony, who is the owner of a startup called Digital Corals, and he's working on essentially what you're doing there, but I think on perhaps a wider scale, and the importance of knowing like exactly where corals have come from, and I think including wild coral as well, and how in future it may be. I think thinking about sustainability and stuff going forward as well, to know origins and things like that can be really helpful when it comes to it's I think he's still working on how he's gonna do it all. There's talk of it all interlinking with even like cryptocurrency and things as well, and the whole kind of digital side of things where this may well go in future. It's a little bit beyond me, but I think he's working on simplifying it all before bringing it to the market. But what you say there really reminds me of what he's kind of working on, and the whole NFC chip thing. I think it's a really great idea.
Yeah, it has a lot of very interesting aspects. One for the regulatory side of things, that
yes, absolutely.
If we send corals to a non-EU market, right, and the veterinary who has to clear the shipment can just hold their digital device to the coral, and it says them the CITES number, the species, when it was spawned, etc. I mean, that's makes things a lot easier.
Yeah, that's a very cool innovation as well.
Yeah, and for us, it was also just like a little sign to say, okay, we try to be very transparent and about this, and because we are the first that do this, and and the authorities are also like, for them, it's also really new, and they really appreciated the effort from us that we don't go this extra mile, that we don't have to. I mean, they don't have to have a tag like a bird has, for example. But they really appreciated that we try to be very transparent and make it more easy to.
So in the within the EU, the corals don't have to be ID'd basically by individual, but so we're IDing animals that are not
mandatory.
They're not mandatory to be ID'd on an individual basis, so that is something the authorities quite like. And for us, it's also
for us, it's just a matter of keeping track of things.
Track.
We have different generations of like the corals, and there is a variety of how big they are. I mean, and we know a lot of them like personally, but not everyone.
and optimizing as well. So the way it works is that the NFC tags that are being put in there basically have their own serial number, and once it's written onto the tag, we can enter information of different attributes, like from fertilization, a lot of things basically, right? And then some of these attributes are how would I say, they're like released publicly. So
and some of them are just for us basically to keep track of, like if we try different methods, like how they develop over time, to keep track of things. So
for optimizing.
So what Tony's kind of doing, because where we were talking about like the public's feelings as well on the hobby and things like that, is he's, I believe, it kind of bringing it to the blockchain so that public can also like own parts of coral that's in hobbyist tanks, and that will again go towards funding reef restorations and things like that. So it's tracking its growth, tracking, you might frag a bit and then it goes into someone else's tank and then that's registered, and it's a super interesting concept that again I've not fully grasped it, but what you're saying there, it sounds like that could be a really cool perhaps chat or something between you guys. Sounds really promising.
Yeah, there's just, I mean, some of these that you have are just phenomenal.
Yeah.
You know, it's not every day. It must be really unusual when you go to parties and people say, "So what do you do?"
Yeah.
Oh, I make these really unique corals that are one of a kind.
Yeah.
Well, I have to say, at the moment, we don't
go to parties.
we don't attend too many parties.
We have a small child and a business that takes up all our time.
That'll do it. Yeah.
Yeah,
And the parties we do go to, like at Reef Mania,
Yeah,
then
everybody knows what we're doing because they're all coral.
Coral party. Yeah.
yeah, these are just amazing. And like I said, this is why I was so excited to have you on, because I've got a bit of a glimpse of this when we were at the Reef Summit with TMC, and it just really opened my eyes to what was out there. It was great with Jamie talking about the process of spawning corals and the idea and all the restoration work that's going on. But then you see like these corals that there's just nothing like them. They're just so unique, and yeah, just to see them was phenomenal.
Yeah, and that was a year ago almost, right? That
Yeah.
you saw it. They were tiny then. These guys, all the guys you see now, they were like half a centimeter then.
Yeah,
Yeah, a little bit bigger maybe, but yeah, they.
I mean, you
Going
seem to
along.
have cracked.
Yeah,
the code.
that's a good one.
Yeah, that's an interesting one. That one is a bit
that's
older,
funky
and
one.
yeah, you can see they're siblings. Both sides are siblings, and the growth form is completely different, right? I mean, you would think
Yeah.
these are different species. The two
Crazy.
Yeah.
sides of this colony. You would really think like this cannot be the same species, but it is. They're actually siblings, so and
Yeah.
they are.
It's
so
almost
close
like, where's the
together.
damage where they're stinging each other, you know?
Yeah, no. Yeah, sometimes you see these pictures. Like once I saw a picture, was like, oh my god, what kind of chimera is that? And you can see like people just like cut up corals and like
Sure.
put them like a bouquet
Yeah,
of
yeah.
flowers like next to each other just to take a picture. But no, these are real.
Yeah, corals are weird, man.
Yeah, I mean, I could sit here all night talking to you about these, but I'm very mindful.
I didn't.
I've got that on my computer. I'll show that in a second. I'm just very mindful that it's gone 11 p.m. for you guys. So
Blimey, that went quick.
Oh yeah,
Yeah. I don't want to.
Yeah, that's
I don't want to.
the Millipora. We have got Millipora also in the pipeline.
Yeah,
I think that's a species that takes some patience for the
That's
people
why I had to
spawning them.
laugh about the name, the impatient reefer. I am an impatient reefer as well. I'm not a patient person. I don't know why I do this. The Millipora are they're taking.
Yeah, but once they
there
found
there's
their time to
Yes.
shine, then
They will be good. In half a year, we will have really good Millipora, I think.
half a year? No, before that.
Yeah, a few we will have earlier, but in like half a year, we will have a lot of really nice ones.
Yeah.
So I've got 2 more videos that you sent over to me, but I downloaded those 2 because I can then play them and the audio adds on and everyone can hear it and everything. So I've got those here. So one of them is your one about what is a chimera, which is
Oh
this
yeah,
one
I just
here.
uploaded this
What
today.
a coral
Actually,
chimera looks like.
Let me try that again. Let me remove that one. And I'll put this one on.
Know what a coral chimera looks like? No, that's not it. This is a chimeric coral. A chimera is an organism composed of 2 different individuals. In corals, this can naturally happen. When 2 larvae settle next to each other, they can fuse and become these gorgeous, beautiful 2-colored colonies. Some coral species can be grafted, but for acroporas, that doesn't seem to be the case. There is only a really small window right after settlement where they can fuse with another partner. Coral chimeras can occur in nature, but they are very rare. We spawn acroporas in our facility and can affect the early development to get more of these gorgeous chimeric corals. In very rare instances, 3 larvae can fuse together, like this one. A purple one, a blue one, and a green one all fused and became one colony.
Wow.
Awesome.
And then I have one more here.
Yeah, that's actually the same footage, just a little bit longer. Of course, for the
Okay.
videos on Instagram, they always need to be so short.
Yes.
So I always try to only have like 2 seconds or something per colony.
Yeah.
So yeah, I thought maybe when we just talking, we could have a bit longer for each individual. So it's just footage of all kinds of different chimeras that we have. So we have a few, but yeah, they're definitely very limited. We sold a handful, not very many. But yeah, we're working on just making quite a bit more for like next season.
Yeah, in the future, we'll hopefully be able to supply more numbers of chimeras to a more.
I like that one a lot. That one's
that one. Yeah, that one's good.
Is that one you've hidden so that you get to keep that one?
Out the back.
I actually only have one coral that I call my coral. I mean, of course, there's a lot of them that I really like a lot, but there's one that I mean, you could pay me, like, if you would pay me like $1 million, of course you'd have it. I don't know exactly for what I would give it away, but like, it would have to be a lot.
Yeah,
I fell in love with that one when it was tiny. It was already shining so much, and like still now, everybody who looks in our tank says this is the most beautiful one. So yeah, it's someday I will do frags of it and sell it, but right now it's untouched and it's a perfect, absolute perfect colony.
Yeah, it's one of the more icy blue kintias that has the like turquoise pale inside and then the really vibrant dark tips and a really nice colony shape.
I sometimes put pictures of it on Instagram, and every time a lot of people ask me to buy that one, I want to buy that one. Oh, I'm sorry. Any other?
Yeah, it's fascinating what nature can produce.
This one I like a lot too. I like both of those colors are really vibrant. It's a cool one. Doesn't have the like a lot of splice branches, but it's really cool.
Then a while ago, after sales started, so I look at the corals. I look at basically every coral every day, right? But in a more technical sense, I go through them. But like we also do the coral shower, I call them, to rinse out all the sediment once a day. So I go there with a tubing to blast off the sediment. I look at like polyp expansion, tissue thickness, how does the base look, how's color, all the technical stuff. Like go through every color.
You only look for problems.
Yeah, every coral I look at, like the technical process. And then after sales started, then Mareen was talking about.
I was always at the tank. Oh, it's so pretty! It's so beautiful.
Grading and these colorations and that, and then you asked me if
Did you even like really look at how beautiful these corals are? And it's like, not actually, no.
More like a technician checking, I don't know, engines, like everything in order. Is there any problem?
So we have very different parts. We can kind of do most things. Both of us can do most things that we do, but we have different jobs basically. So I deal with all the pretty stuff. I do all the frags and grade the corals and sort through the corals and stuff like that. And he's always with the mother colonies where all the problems are. It's like, I don't even look at them. It's like, you can deal with the stupid mothers. They're annoying.
And all the technical stuff, all the devices that stop working or whatnot. All the digital joys of business, I have to say. Especially after we set up that system with the NFC tags that then correspond with our
boring stuff.
Yeah, it's boring.
Boring
stuff.
computer
But
stuff.
it takes up 75% of my day. That boring stuff.
Well, whatever it
Well,
is
that's
you're
all the
doing, you're
software.
doing it right.
Absolutely.
Yeah, agree.
And I sit at the screen until 5 p.m. or 6 p.m. and
then you go to the
then I
aquarium.
go repair stuff.
Yeah, we've just had Ty join the live stream, and Ty is always famously late. He always turns up in the last 5 or 10
At
minutes.
the end, yeah.
And he said, "What sorcery is this, and how much poorer will it make me?"
There was a first meme about us today. I had to laugh so bad. It was this meme, you know, where this couple is walking down the street and the guy turns
Oh
around
yeah,
and looks
looking
up at the
backwards.
woman,
Yeah.
and the other woman was SciReef's chimera corals, and the woman that was mad was his monthly rent.
Yes.
Yeah,
Wow.
so yeah, you'll be like $1,000 for when you buy a chimera from us right now. So
Yeah.
be a bit more patient. We
Yeah.
will try to make more of them so we can make them more affordable. This is just the first month, first run to enter the market.
Yeah, first batch.
First batch to enter the market. So
Yeah.
I apologize.
They are phenomenal. I mean, the live stream has lived up and exceeded all of my expectations. That's why I was so excited to get you guys on. And like, here we are. We're over 2 hours in, and I've still got a big silly smile on my face because it's just been so much fun. So
yeah, it's
thank you
fun.
so much.
Yeah, that's been a lot of fun.
I guess you can tell we love corals and we love talking about corals. So.
For sure. Yeah.
Yes. Yes. Well, thank you very much for coming on.
Thank you, guys.
It has been phenomenal. And Ty, you really need to go back and see some of the
Rewind.
gold that we've been through tonight.
I mean,
It's
if
been
it
amazing.
weren't past 11 p.m., I would say we could do another 3 hours, go into details of everything. But
we can do another one in like half a year.
I'm sure Steve will have you back.
This opens it up. We can get you back on. So yeah, that would be phenomenal. Yeah, definitely.
No,
So,
it's really been a lot of fun. Yeah.
And thank you guys for doing this. I know it's a lot of effort you have to put into put out podcast, and it takes a lot. So thank you. I'm very grateful for everyone that does something for the reefers community.
Yeah, thank you. Thank you very much. There's gonna be another little video that I'll play as an outro. When it finishes, there'll be a bit of a pause, and then it will say, I think it'll only say on my screen, "You're off the air," and then I'll add this back to the stage, and we can just have another 5 minutes, and then we'll go. So don't when I play the video, don't just leave.
Okay.
As a lot of people sometimes do. But yeah, thank you so much for coming on. It's been brilliant, and to give up your evening to talk to us about it. Thank you, Harry, for coming on yet again.
Anytime. Pleasure.
Yeah, hopefully you've enjoyed this
absolutely
as much as I have, even half as much as I have. You'll be over the
it's
moon.
been fantastic.
Thanks, guys.
Thanks.
Thank you
And
so
now
much.
I know who's behind the spiritual reefer because I saw.
There you go.
I was like, that's an interesting thing. I already followed you now.
Excellent.
Brilliant. Well, thank you very much for everyone that's tuned in as well, and I'll see you all next week.
Take care, everyone.
Stay